In this module, you will learn about the concept of Boolean function operator, the simple Boolean function in SOP and POS form, the rules to simplify or expand Boolean functions, the methods to simplify the Boolean function using K-map and algebraic function, the correspondence between Karnaugh maps, truth table, and logical expressions. Let us begin the session by understanding about Boolean functions operator. Boolean function operator can express algebraic expressions in logical function. It can be defined using truth tables by forming a Minterm and a Maxterm. A Minterm or standard product term is obtained from AND operator if combination of complemented bit is 0 and normal bit is 1. These terms are denoted by small m. A Maxterm or standard sum term is obtained from OR operator if combination of complemented bit is 1 and normal bit is 0. These terms are denoted by capital M. Next, let us learn more about AND, Minterm, function operator with the help of an example. On-screen table shows Minterm for 3 different variables A, B, and C and corresponding values 0 and 1. Note that if the corresponding bit of binary number in the truth table is 0, then the binary variable is expressed in complemented form. For example, A complement for variable A as shown in first row. And if corresponding bit of binary number in the truth table is 1, then binary variable is expressed in normal form. For example, A for variable A as shown in fifth row. Here we can see that input variables of A, B, and C are denoted in short notation as values of Minterm. For example, in the first row, A complement into B complement into C complement is the output of the variables A, B, and C. There will be 16 minterms designated by M0 to M15 for 4 variables. Let us now look at OR Maxterm function operator with an example. On-screen table refers Maxterm for 3 different variables A, B, and C and corresponding values 0 and 1. If the corresponding bit of binary number in the table is 0, then binary variable is expressed in complemented form. And if corresponding bit of binary number in the truth table is 1, then binary variable is expressed in normal form. Here you can see that input variables of A, B, and C are denoted in short notation as values of Maxterm. For example, in the first row, A plus B plus C is the output of variables A, B, and C. There will be 16 minterms designated by M0 to M15 for variables. Now let us compare Minterm and Maxterm function operator from the previous example. You will notice that for every Maxterm, there is corresponding Minterm. Now let us learn Boolean functions for n variables. Minterms is standard product of n variables. For n variables, possible number of minterms is 2n. Minterms is denoted as shown on the screen. Maxterms is standard sum of n variables. Each term of Maxterm is complement to minterms, denoted as shown on the screen. Detail about algebraic representation of Boolean function with help of truth table is covered in the next few slides. Let us now understand how to express Boolean variables in algebraic representation. There are 2 ways of representing variables. They are 1. Canonical form, 2. Reduced or simplified form. Let us look at each of these methods in detail. Canonical form is a Boolean expression consisting entirely either of minterm or maxterms. Canonical form is represented in two types. They are 1. Canonical sum of products, SOP form. 2. Canonical product of sums, POS form. SOP form of Boolean function representation are those variables which are obtained by combining and of input producing output 1. And all these product terms are further added or together to get the final function. Here is a simple example that implements sum of products SOP in Boolean function. In this example, as you observe, we have Boolean function defined on 3 variables. So, A, B, and C are inputs of F1. As shown here, function for case 1 is 0, case 2 is 1, case 3 is 0, case 4 is 0, and so on. From this, it is clear that A complement into B complement into C, A into B complement into C complement, A into B into C complement, and A into B into C are minterms resulting into output 1. Hence, algebraic representation of the function f will be as shown on the screen. Function in SOP form can also be represented in minterm designation and mathematical representation. From previous example, you see that if minterm is denoted in short notation, you can express function as m1 plus m4 plus m6 plus m7. This is known as minterm designation. Same function can also be expressed in mathematical way as shown on the screen. Now let us understand about canonical products of sum, POS form. POS form of Boolean function representation are those variables which are obtained by combining, ANDing, maxterms of input and producing output as 0. Now let us look at how products of sum, POS form, can be implemented in Boolean function. Here is a simple example that implements products of sum, POS. In this example, all the maxterms shown on the screen result into 0. Hence, algebraic representation of the function f will be as shown on the screen. Function in SOP form can also be represented in maxterm designation and mathematical representation. From previous example, if maxterm is denoted in short notation, we can express function as m0 dot m2 dot m3 dot m5. This is known as maxterm designation. Same function can also be expressed in mathematical way as shown on the screen. Now let us look at both SOP and POS expression for the same function. In this table, SOP expression, whose output should be 1 for f, is as shown. Also, you know that POS equivalent of it is found using complement of minterms with value 0. Hence, the result for f will be as shown on the screen. Now let us understand how to quickly convert canonical form to another. Shortcut for converting one canonical form to another is 1. Interchange the symbol or to and or sigma to pi. 2. List those numbers which are missing in original. Let us now look at another type of algebraic expression, which is simplified expressions. Simplified or reduced form helps to reduce an expression easier to understand and less prone to errors. There are many ways to reduce, but in this session, we will understand two ways. They are 1. Algebraic manipulations, 2. Karnaugh Map. Let us look at each of these methods in detail. In algebraic manipulations reduction form, in order to minimize a function, various theorems and axioms can be used. There are no certain rules for minimizing a function. It depends on individual choice to apply Boolean theorems. Let us look at few examples to understand the concept better. In this example, as you observe, various theorems are used to reduce same function. Algebraic transformation can be reduced in optimal form, but does not guarantee same solution every time or reach to same output when done by different group of people. Here is another example that shows reducing expressions using algebraic manipulations method. Here is an example that illustrates how to convert reduced form to canonical form. The next method of reduced or simplification form is Karnaugh Map, K-Map. Karnaugh Map, K-Map, reduction form is a method of simplifying minimal Boolean expressions using truth table.